Hello, students. This is Mr. Morris. Welcome back to CAD 120. And today I'm going to show you how to work with some of the geometric dimensioning and tolerancing symbols. Now, please understand that topic is actually a 16-week course. So we're just going to hit the highlights of that, of how to apply these symbols. Okay. But I encourage you, if you're especially a CAD student and you want to continue on working towards a CAD Associate of Applied Science degree, that might be a class that you would take. Okay. So I'm going to go ahead and, if you don't mind, share my screen with you. And that's not the screen. Hang on just a second. I'm sorry. I had this. Got to pull up the right screen here. So let me share again. All right. So this is the right screen here. I'm going to show you what we're going to do. This is the model that we're going to create, and you'll see that I have some dimensions that are metric and some in English. And so it was a mistake that I made, and I realized, hey, this is actually a good chance to learn how to change your dimensions from millimeters to inches right on the drawing itself. It's pretty easy. Here's the part. Okay, so we're going to model this part first based on the dimensions we have here, and we'll go from there. So it might be what I might need to do, though. I see those dimensions are already, that's probably, I think it's 2 inches. 50.8 is 2 inches. The other dimensions are given to us. Okay, so here we go. So please go ahead and click on OnShape. All right. Once you click on OnShape, select Create, and then select Document. And we're going to call this GD&T. GD&T and Create. Now, the boo-boo that I'm just going to do the same boo-boo so I can show you how to fix it. What I did was I went up here with these 3 bars, and I went ahead and selected workspace units, and I changed this to inches. Okay. And I also changed this one. I don't need to change this one, but I did inches per square. And I selected the green check mark. So everything was fine, right? So what I'm going to do now is I'm going to go to Sketch, and I'm going to click on this plane and go to Front. Now, what I did with this block is I went ahead and created the overall dimensions of the block first. So I went ahead and went to center point rectangle, and I came to the origin, and I clicked, and I dragged it out and click. And the first dimension I put in here was 2.5. Okay, enter. And then the other dimension is 1.38. And then enter. All right. So that looks good. That's the profile that I want to extrude. Just double checking my dimensions. Everything looks good. So I'm going to click on the green check mark, and I'm going to get in the isometric view, and I'm going to come over here to extrude. I'm going to click on this part, and rather coming in this direction, I'm going to flip it and go in the opposite direction. And I'm going to make this dimension and hit the green check mark. All right, now there's several ways to do this. You may find a way that works better for you, but I went ahead and just kind of whittled away at this block. The first thing I did is I went here, sketch. I clicked on this surface and I drew a corner rectangle from here down this way. Click. And I took the difference between 1.38 and 0.75. What is that? 0.625. Let me check my numbers real quick. I always like to check even when I'm not even if I'm sure, what the numbers would be. I just still like to double check. So I took 3.75 with 1.38 minus 0.75, and it's 0.625. So this dimension right here, since I already closed it out, I'm going to go ahead and use this dimension tool here. This dimension here should be 0.625, green check mark. And then I'm going to apply this same dimension. You could have just left it like it was, but I closed it out for some reason. And this is going to be 1 inch. 1 inch. You don't have to put the I in there, but you can. All right. Then I got my isometric view and I went green check mark, extrude, click on that face. I'm going to flip direction and I'm going to pull it all the way across. And I'm going to select remove material and select the green check mark. All right, we're making good progress. All right, now we're going to whittle away up here on this corner. So I'm going to do the same thing. You could have just sketched that profile and you very well may have done it that way, and that's okay. But I did it with 2 rectangles. Kind of missed my mark there. Hang on. All right. So this dimension here is going to be 0.5. Enter. Okay. And then this dimension here is going to be the difference between, I think this is going to be 0.25. 0.25. Enter. All right. Think that's good. Hit the escape button to get out of that command. Hit the green check mark. As I tell you, my hardest part is hard for me to see sometimes the sketch itself. Come over to extrude, and there's probably a better way of doing that too. I'm going to go the opposite direction, drag it over, remove, green check mark. Are y'all doing okay? I'm assuming y'all doing okay. All right. Now I'm going to go ahead and come over here to the backside, sketch, click on that face right there. We got to cut that out, that little notch. So we have a little notch there. And it's basically looks like this. I'm going to use this corner rectangle here. I'm going to click right here. And I'm going to drag a rectangle like this and click. Now I know that dimension is going to be 0.88. Actually, it's probably more like 0.875. That's okay. 0.88. And this dimension here is going to be, hang on, my good friends, 0.375. 0.375, enter. All right, now I'm also going to put a dimension right here. Now I shouldn't have to put one here. See, it's not going to let me do it anyway, I don't think. Well, it might. Let's see. All right, so it did. So I know that's correct because the overall depth of this part is 1.875. So I'm going to hit the escape button, go back to isometric, and I'm going to click on the green check mark and select extrude. Select here, and I'm going to go opposite direction like that. Remove. And click on the green check mark. All right, so all these planes are like, cluttering my picture here. So if it's okay with you, I'm going to turn those off. So we can see our geometry. And I got to put a hole right here. Okay, got to put a hole right here. So I'm going to go to sketch, click right here. Okay. And we're going to put a circle, center point circle, about right here, arbitrary location, click, drag, click. Now the diameter of that circle is 0.75. 0.75, enter. Okay. And now we're going to have to apply some other dimensions to locate the exact center of the circle. And that's going to be 0.5. And then we're going to put another one here. See if it lets me do it here. I tell you, Autodesk Inventor spoiled me. Anyway, so there is our hole. I'm going to click on the green check mark, and we're going to extrude this. Now, there's other ways to make holes. You could also use this feature here, right? But this is when you want to use tapped holes, counterbore, stuff. If it's a simple hole, you can just use the circle command. I'm gonna drag it the other way and remove. All right, click on the green check mark. Y'all doing a beautiful job. All right, now we want to put a chamfer here around the edge and then a chamfer at the bottom. So right here is our chamfer tool right here. Click on that. And we're going to click on this edge. Now that's a very big chamfer, right? So we got to modify it. And it is 0.03. 0.03. And the chamfer is at a 45-degree angle. So this should also be 0.03. Bill, you okay? All right, cool. All right, and I'm going to hit, no, I'm not going to hit the green check mark yet. Look what I'm going to do. I'm going to go to the other side and do it the same while I got it up here. Now I'm happy with both sides, top and bottom, and select the green check mark. Okay, here's where if you wanted to, and this is where I recommend you do it, you could right click on this and you can assign a material for the part if you want to. You can come over here and come to where it says none and arrow down and find, a material that is desired. There's quite a few there. I'm not going to apply a material to it. Well, I think I'd use copper one time. Select the green check mark. But it doesn't do anything to the appearance. So it is copper, but it's blue. So like an Inventor, when you do that, it makes it look like copper when you assign the material. So I'm going to right click on this, edit the appearance, and I don't know, I'll make it look somewhat like copper, maybe. I don't know. Is that close enough? Green check mark. All right. I don't care what color your block is, whatever color you choose. Now we've got our geometry here. And rather than making the mistake that I did yesterday when I was playing around with this, when I created a drawing, you go down here to the plus sign at the lower left-hand corner, click on the plus sign, and you want to create a drawing. And you want to make sure, see right here, it says millimeters. That was my mistake. Okay, I chose that one. And I should have chose what? This one. You see this? I should have chose this one. And I'm going to choose this one to do it right. But I'm going to show you how to change a dimension. So in case you have a small drawing, something, oh man, I forgot to change the dimension. You can right click on it and change it real easily. So we'll pick this one here, okay? We'll pick that one and say, okay. Now, but what I think we also need to do to be careful about this is we might want to come up here and check our workspace units and make sure it says inch, which it does. All right, so we're going to go to insert, and this is the part. And I think I left it as a, let's see. I think I made it 1-to-1. I think that's what I did, made it 1-to-1. If you want to make it larger, you can, but you might run out of room. Then again, you might be able to squeeze it all in there. All right, so we are projecting now. Click, click, come over this way, click, come over this way, click, come back this way, click, and go at the 1 o'clock position. Hold your breath, click, escape. All right, you can reposition these around some. Now notice there's no hidden lines here or none here, and really you want to show the hidden lines. Sometimes you might not want to, okay? Sometimes you might not want to, but in this case we want to. Sometimes you can have too many hidden lines, it clutters the drawing. And when that happens, you as the engineer is going to have to decide, the possibility of using a section view, right? Instead of using hidden line, use a variety of section views. I'm gonna right click on this and I'm going to show the hidden lines. Same thing over here, right click here and show the hidden lines. Okay, we're making good progress. Now notice there's no center line for this hole in the front view or the right side view. So we're going to apply the center line here, and this is the tool I use right here. Click, there's one, and click, there's two. All right, so we have a center line there. All right, now we're going to start dimensioning this. And so what I did, I'm also going to show you how to add some geometric dimensioning and tolerancing symbols. That's beyond the scope of this class. I'm going to tell you what it means somewhat, but there is a whole semester course just in that, okay? All right, so I'm going to go to dimensions. Some of y'all are probably ahead of me, which is fine. You guys want to take off, that's up to you. Boom. There's our first dimension right there. We'll do another dimension. I kept saying boom a lot yesterday. Boom. Okay, there's another one. And then we're going to put a dimension here, the overall. Try to keep your dimensions so they're uniform. You keep a uniform spacing between them best you can. Then we'll come down here, click here and here. This is I can see now I've got like a little bit of a boo-boo here. I'm not sure yet where the error is. It might be that I've added too much here, or it might be my block is too short or too tall or whatever. We'll find out. Right, 3. That looks correct there. Please understand when it seems like Mr. Morris is moving a little slow, it's because I work with like 8 different CAD software packages. So I'm thinking I'm not even going to bother changing that. I'm just going to leave it as is. I could go into the model and change it. Maybe I should do that. Maybe I'll go on the model and change it. Um, it's going to be right here. You can make it, turn it on and do a right click on that and edit the sketch. So what should have this dimension have been if it's, what, someone take 1.375 and minus 0.75. Tell me what you get there. There's a point.
1.38.
I take 1.38 and subtract 0.75. I think it's 0.3 because it was making it two decimal places. 0.62, 0.63. All right, let's do that. I'm just gonna do that. Look here, I'm gonna green check mark that and do the green check mark here. And I'm gonna go back to the drawing and let's see if I'm just gonna see if that changes it. All right. I'm gonna go in there and change it that way. It's not liking me because it's putting the underline. I'm not sure why that's not coming out. Anyway, I'm not that worried about it right now. I know it'll change rather easily. I'm more concerned. You already know how to dimension a part. I'm more concerned about showing you how to put let's put some dimensions up here as well, even though we've already dimensioned this. We've already dimensioned these here. But we didn't dimension that one. So really, if you look at this, we've already got these two. We could take these dimensions out, and that's why I recommend we've already got these. Just do a right click, delete, right click, delete. Why put a dimension there you don't need, right? That just makes it harder for the person who's going to make it try to figure out what's going on. Okay. Now we do need some dimensions here. We need a dimension here, here, and then here, here. All right, so I got rid of those dimensions at the top there. We didn't need those. I'm gonna come over here and put the dimensions over here now that we need. And then after that, we're going to start applying the geometric dimension and tolerance and symbols. Click here, here. Oh, there's an error. That might be part of the problem. Okay. I didn't realize I'd done that. All right. It looks like we have all the main dimensions that we need. I mean, we could put a dimension right here. It wouldn't hurt matters. Put one right here. And we see that purple line show up. Escape. It doesn't like that though. Let me do this. I'm going to delete that. Hang on just a second. Just hang in there with me. We're almost done. Okay. You can do that. All right. So I'm looking here and it looks like I have all my dimensional data for the most part. You don't dimension to a hidden line, just you can dimension to a center line, but you don't dimension to a hidden line. We're going to go ahead and shade this right here, edit this, and show shaded view, show shaded view. All right, looking good. I hope y'all's is probably looking better than mine. All right, we have a chamfer down here. We need to tell the size of that chamfer. And if you don't put that same note at the top, it's understood to the machinist making the part that you want the same chamfer. So if you go right here where your dimension tool is, and you'll see the chamfer dimension, click here. All right. And click here and this line. You click both of those lines. And you're going to have to use your scroll wheel to place that about right there. Very good. Now it looks like I have all the dimensions there and all the dimensions there. So now I want to come in here and apply some. I want to first place my datums. Datums are your reference edges or surfaces. So if you go up here, you'll see the datum. And we're going to attach one datum right here, but I'm going to bring it down like this. And I'm going to move this over some, about maybe right there. What that means is that surface right there, that surface or that edge is datum A. Okay? All right, now we're going to put another datum here. And a lot of times I apply these datums all at the same time, but it's going to do it in alphabetical order. We already got A, so now we need a B. Click here, hit escape. Now we can move this up like I have on my drawing if you want to. You can do that. That means this edge or this surface here is datum B. Now we have one more datum, and that's over here. So we have three planes that defines this geometry. And again, you will learn more about this in CAD 128. All right, now what we're going to do is we're going to come in here and we're going to start putting in these geometric dimensions and tolerancing. The first one I'm going to do this edge right here. Come right here, right beside the datum, you have this other icon called geometric tolerance. Click on that. And we want to make the symbol parallel. And we want to make the tolerance here 0.002. So 2/1000ths of an inch. And with respect to datum A, and now we're going to click, click, and we're going to we're going to drag this out like this. Click, escape. Now, what that's saying is this. What that is saying, this edge right here is parallel to the datum within 0.002 inches. If you have a top, that would be your tolerance zone. That's your allowance if you have a variation. So it is a tolerance. But this line has to be parallel with this one. And the way you would check it is you would put this on a surface plate, which is a precision measuring or precision surface, right? You would place this on, then you would get a dial indicator and you would run it across here and see how much off. If you're less than 0.002 as you run your dial indicator across here, you're good. But if you exceed that, then you got a problem, right? All right, so that's the first one. Now let's put another one here. And again, I mean, I don't use OnShape every day, so I do make mistakes. And thank you for catching them, and thanking you for sometimes figuring out a different way of doing it. But we have another one here, another parallel, and this one is 0.003 with datum C. And we're going to plug that in right here, and I'm going to drag it up. Let me try that again. Sorry. Come here, parallel, 0.003, datum C. There we go. It's like a little flag. Now, what that is saying, look here, is saying that this surface here is parallel to this one. Now, this surface is what? C. C is down here, but those two surfaces are the same. This is just the top view of that surface, right? So it's saying it's parallel to datum C within 0.003. Again, you could lay this on a surface table and run you a dial indicator on this edge and make sure it doesn't go any higher than 0.003. Okay. All right, the next one we need to put, we do need to dimension our hole. And I'm sorry we didn't do that. I should have done that. All right, so come in here, we're going to put a dimension for diameter. And I'm going to click on the inner hole because that's the one that's actually diameter. Now watch very carefully, click. This one has a tolerance. It has a symmetrical tolerance. So we're going to click on here, and we want it to be symmetrical, and we want it to be 0.005, 5/1000th of an inch. And it should look like that. Hit your escape. Does yours look like that? All right, good. So that takes care of the tolerance associated with the hole. There's also something called a positional tolerance. So go to this here. This is your positional tolerance symbol right here, positional. And our tolerance is 0.003. Okay, now look, we're going to have to use arrow down. We're going to have to use a maximum material condition. I'll tell you what that means in just a minute. Click on maximum material condition. And we're going to have, with respect to datums A, B, and C. And I'm going to put that about right there. Green check mark. Mr. Morris, what in the world does that mean? First of all, a positional tolerance is normally associated with a circle or a hole with an axis. You with me? And then it's got it's almost like you have another imaginary circle at the origin, right, or at the center, and your actual center could be anywhere within that circle. Your actual center for the hole could be anywhere. That's your tolerance zone, and it's going to be that way with A, with this datum here, A, and also B and C. So it's concerned about all three datums. Now, what is max? Okay, if you don't learn anything else today, let me explain to you what maximum material condition is. With a hole, if you drill a hole, the maximum material condition, if you have a tolerance associated with it, is always going to be the smallest hole. So why is it you're trying to maximize? Well, the more material you have, the smaller hole means you have more material left, right? A larger hole would mean you have less material. You remember that? Smaller hole, more material, larger hole, less material. So when you maximize the material condition of a hole, it's smaller. Okay. Now with a shaft, with a shaft going through a hole or a rod. When you maximize the material condition for a shaft, it makes it larger. The shaft is larger, the hole is smaller. In other words, you're increasing the amount of material. That's all you're doing. Okay. And I'll save the remainder of that for when you take a higher level class if you wish to do so. It used to be, look, it used to be that we just worried about these type of tolerances here. But then we started worrying about not only the dimensional tolerance, we worried about the geometric shape of the part too. So that's when they added the geometric dimension tolerance and symbol. I tell you what, it's good to know those. Okay. But it's outside the scope of this class to focus too much on that. How many more of those we have 3 on this other side. Now I was doing this last night. I was messing it up for some reason. I'm gonna see if I can make it better today. We'll see. We have another positional tolerance here, and actually, we don't need that because it goes with a hole that we didn't put on this block. There's another hole that we didn't put, and I left it off. I missed it. But so we won't put that one there because that goes with a hole. Um, however, we are going to put geometric dimension and tolerance in here. This is going to be perpendicularity. Perpendicularity is perpendicular. Okay, and it's within 0.002 with datum A. And for some reason, you guys might get this to work. Mr. Morris had a heck of a time. Like I still am. It looks like my arrow's crooked. Okay. Well, the leader is actually supposed to be bent slightly at an angle anyway. I think that's good enough right there. I wasn't sure why it wasn't giving me a flag option like this one here. I played around with that forever and I didn't get it to work. So maybe you can get it to work. Okay. But let me tell you what this means. Let me tell you what this means. This line right here, this line is perpendicular to this line, isn't it? You see that, Bill? You see how this line right here is perpendicular to this one? You see that? Okay. Now, what that means is you have a tolerance zone around this line. In other words, it could be plus or actually 0.002 two thousandths. That line can be, look, it can actually be slightly, a very slight angle, very, very slight angle. It's still 90 degrees, quite, but not quite. Again, because your tolerance zone would be around this line right here, and you have a little bit of flexibility. But granted, what is 2 thousandths? What does 2 thousandths of an inch look like? Remember, I told you, look, piece of paper is how thick? 5 thousandths thick. So it's not even half the thickness of a sheet of paper, 2 thousandths. You see what machinists have to machine to, right? That's pretty significant. Okay. All right. We're gonna put one over here. We have another parallel, a lot of parallels. And this one's 0.002 with datum D. Click on this. Ah, That one worked that time for that one. What about this one? Okay. I'm going to leave a good thing alone. I'm not going to mess with it. I got it to work. There's something I'm doing wrong with the, yeah, maybe you guys will get it to work on yours. Okay, fellas, I'm okay with that. You might, now, let me show you something. Let's say you did this whole drawing, right? Riley, let's say you did this whole drawing. You say, oh man, it's supposed to be metric. Okay. Now, I'm pretty sure there's a way of doing it all at one time. But if it's just a few dimensions, Bill, look here. You can do it. Look, watch. Right click on the dimension and come down here to where we say edit. Oh, sorry, not edit. Right click on the dimension. Why is it not giving me that chance? Oh, I think I know why. I think I know why. It's not allowing me to do it today. Oh, here we go. I'm sorry. It does allow you to do it. Mr. Morris is having a senior moment. Right click on the dimension, edit. Look. Change to millimeters. Look. Boom. Let's say you just want a couple of dimensions to be in millimeters. That's got 3 decimal places too, so that's pretty significant. But we didn't change that. Okay, so I can undo that. So I went around changing my dimensions last night. Now let's come down here and put checked by you. And this is 0529.6. Approved by me. Again, 29, 0529.26. Right here, this first line would be VPCC, delete all that rest of stuff there. Check mark. CAD 120, delete the line. Sorry, not 29. And this would be GD&T. There is also another thing I want to show you real quick, a surface mark or a surface finish. Click on this. You can click on, look, and you can put in your information about that as far as the, well, I need to find one here. You know what, I'm not going to worry about it because I wasn't prepared to do that one. But you need to have some additional information here that goes with your surface mark. Let me see if I can find one. Hang on just a second. I don't know if I can. Okay. Seeing if my phone works in here. Usually it doesn't. I tell you what, I'm just going to give you another little small exercise, not today. Probably, we'll probably just come right back to this drawing on Monday and we'll apply the symbols here. But the main focus on Monday is your test. Okay. So I'm going to stop this share and I'm going to say goodbye here, stop the record.